All right, welcome to class today. I hope you all had a delightful holiday. I just want to talk a little about where we sit. So this week, each section is doing something a little bit different. Right now, actually, both sections I teach are doing the same. Both sections still are doing the same, although we may change that. So we'll talk a little about what that involves. Professor Dill and I have scheduled a meeting for Friday to decide how we're going to evaluate this on final exam. Sorry, I don't know that yet. But I also wanted to point out that just in case you were unaware or had forgotten, you do have another game checkpoint on Wednesday. As written up on the assignment write-up, this one should be at least the beginnings of a functional game. And that will be coming out. You'll also, of course, have your final game project due a week from tomorrow. Because university policy says that after the end of classes, the only thing we're supposed to have due is a final exam, and this is not that. There will not be late submissions accepted for your game project. However, you can submit as many times as you want, so I would encourage you to submit that early and then keep working on it if you want, and submit again if it gets better. That's a fine way of going about that, making sure the deadline doesn't catch you unawares. Also, we have a homework assignment due Friday, based entirely on stuff we talked about before Thanksgiving break. So I would encourage you, if you haven't already, to begin on that. It will be perhaps a little bit larger than some of the other ones, not dramatically so I don't think, but worth starting a little early and making sure you understand what's going on there. Questions about the things that are coming up? Or other questions you have for me at this point in time? Yes?
For the final exam, do we have to worry about the turtle stuff?
In general, in the final exam, we are not going to ask you about things that we can't easily measure on an exam. So we don't really care if you know the turtle functions. We don't even really care if you understand most of GameBox. We want you to be able to read it and understand how it works, but not necessarily be able to generate the appropriate function calls with their really long names. This is also, I believe, described on the review link for the final exam. Other questions? Okay, let me talk briefly about my plan for the next 3 days. Today we're going to talk about writing files. And we'll talk about why we're delaying this and some caveats with it, but also show you how you can use it to add some useful functionality to things you may be working on with your game, as well as other things. My tentative plan for Wednesday is we'll talk about what you ought to know to be safe on the internet. Not like don't give your social security number to strangers, right? But like about how the internet works, understanding a little bit about that. And I'm open to other topics there, though, so if there's something you really want to know, let me know, and we can adjust what happens on Wednesday. Friday is currently planned to be essentially a Q&A, an Ask Me Anything session. Anything that isn't about the Q&A, that'll be Monday, reviewing for the exam. So if there's other topics you want, that'll be that day. I hopefully will get my act together and send out a form where you can pre-submit some questions. You'll also be able to submit them in the time, and I'll just try to answer as many things about as many things as you ask about. So that's my tentative plan for this week. Again, if there's something you wanted to know, want to see more about, the like, just let me know. Also, there was an email sent out last week that included a link for how you can see feedback from your game project checkpoints. At this point, about 3/4 of you have such feedback, and the remaining quarter I am pestering the TAs to get that done. We'll see how that goes. But other future feedback will also appear in that same link for your game checkpoint. So if you haven't seen that email, go back and look at it. Also in that email was a reminder that if you have a conflict with the final exam, you need to report that in a link at the bottom of the schedule. Today is the last day to do that. So at the end of today, or probably tomorrow morning in practice, I will grab all of your responses, reply, and schedule rooms and so on, and we'll move forward with that. Okay, all that logistics said, let's talk about files. The word file is used in computing, designed to refer to not those sharp bits of metal that can cause rapid erosion on wood, but to these boxes you store pieces of paper in. These idea of file cabinets, file folders, etc., files. And the idea here is to provide long-term storage in a way we can recover from. So the concept of files that we've used so far is we go into the filing cabinet and we read the information there. We go to the disk, we read the contents of the file, and that's all we have done. But sometimes you also want to be able to change what's in the file. You want to change what's on your disk. And there's some caveats to making this work correctly. So let's just do a very brief overview of how your computer runs. You have something called a CPU on your computer which does the processing, does the math and the actions that you're asking it to do. And you have something called RAM, your random access memory, that stores the contents of all of your variables. And together this runs your code. When your code is running, it's running on this part of your computer. There is another part of your computer which is called either the disk, or sometimes your hard drive, or your hard disk drive, or your solid state drive. It has various names. But this is a much larger space than RAM. It can store a lot more than just your current variables. And it lasts. When I turn off my computer, my RAM goes away. Even when I just change from one computer to another computer, my RAM goes away. But my disk will survive. In many ways, the disk is like that filing cabinet. Okay? It will keep what we put in it as long as we put it in there. And the rest of this is more like your desk. When I'm working on some task, I put down the papers related to the task on the desk. I do my work, and when I'm done, I take them off of the desk, put them back in the filing cabinet to make room for the next activity. So things are relatively transient on the desk. They come and go. As I run different programs, different variables are available. But the filing cabinet, the hard drive, can store things for a long time. However, this doesn't work quite like a filing cabinet. It was a nice idea to call these files. It gives some intuition about what's going on. But it also misses some important information. For example, when I read a file, I only get a copy. Reading a file does not remove it from the filing cabinet, does not remove it from the disk. It's still there. The disk makes a copy of the thing in the filing cabinet and sends it to me. It makes a copy of the disk and puts it into RAM. And so nothing on the disk has changed when I read a file. This makes it very safe to open and read files from the standpoint that you can't really mess anything up permanently. I may be able to mess up what my program is doing, but other programs aren't going to care because they have their own desks, theoretically. This is an abstraction that the computer provides. Everybody has their own desk, their own workspace, and only this disk is sort of shared between us. So as long as I don't modify what's on the disk, nobody else can see what I'm doing, and therefore if I do something wrong, the impact is restricted to me. Today, we're going to talk about and show code that will allow us to send new data to the disk. So we call that writing to disk. Reading gives you a copy, writing changes the contents of one of these files. Okay? And that can mess up other programs or your own future. So we're going to try various ways of helping you not mess things up. One is I'm never going to show you the syntax for getting outside of your current working directory. So you're going to write Python programs that only write files in that directory. This will save you from accidentally writing files elsewhere on your computer. Although you could look up how to look other places, it's not complicated. But we're not going to talk about it, partly to try to restrain this. We'll also generally give our files that we're writing a particular naming pattern with a .txt ending and things that will allow us to be more confident we aren't accidentally overwriting another file. So, let's talk about the general process that we go through to write a file. We open with the W mode. We have used open already to open things, but when we open for writing, we need to tell it it's for writing. Open, normally we thus are valid with only a single argument, the name of the file to open. We can also ask it to open in write mode. So I can open whatever my file is with a W, and that means this is open for writing. Just invoking this does several things. It will create the file if it's not there. Okay? So if there's no file, asking to open the file will make it exist. It will also erase what's in it. It is not 100% guaranteed this will happen right away. We'll talk about that in a moment. But in general, just opening a file for writing at all causes its contents to vanish. As if we empty out that folder in our filing cabinet, there's no longer any data, it's ready for us to put things in it. So the very first line can already cause you to lose information in your hard drive if you open a file you shouldn't open. The next thing we do after we open the file is we write to the file. And we'll see two different ways of doing this. Today we'll talk about how they're different a little bit, mostly just use one of them. And the third thing we have to do is close the file. The way your computer works, when I open a file, it puts a little sort of copy of the file in my RAM. And when I write to that copy. At relatively arbitrary intervals, your operating system can choose to send what you've written so far out to the hard drive. This might never happen. It might happen right away. It might happen a whole lot. There are ways of controlling it. But one of the ways to force that to happen is to close the file. So when I close the file, the information I've decided to write to the file actually gets written. So in general, I open the file, all of its contents go away. I call write or some other approach to or print to put information in the file, and nothing changes on my disk most of the time, though sometimes it will. And then when I call close, all of my new information will appear on the disk. So it's important if you write open that you also close. Otherwise, you can just lose information. That said, let's look at the simplest example we can readily do. I'm going to open a file. I'll call it written.txt, and I will open it in writing mode. I will call the write method of files, and I will say this is a test. And then I will close the file. A minimal example of writing to a file. I run it, nothing shows up down here, but when I look at my file listing, I see there's something called written.txt. And when I open it, it has the contents I asked to write. So that information got written to the file. It exists in the file now. The next time I run the program, it will already be there. So I can write to a file. Now, the write method will only accept a string. This is a slight exaggeration, but for all intents and purposes it's true. It is not very flexible, and it also does not add new lines or other nice things we're used to for print. So if I write this is a test and then this is another test and run, first you notice the original this and the test is gone because I opened the file again, I erased its contents. But you'll also notice these two write invocations, the content of them appears right next to each other with nothing in between. Because write doesn't do any padding, doesn't do any new lines, doesn't space things out nicely. It just takes a string and puts it in the file. So we have write. Questions so far? Okay. There's a prettier way of writing, which is to use the same print function we've been using all semester. And of course, we can print anything we want to print. And when I just call print, it prints to the console. But I am allowed to give it a destination to print to. You'll notice the tooltip that PyCharm is telling me right now says I have some number of values. I've already typed those. But then it also has a list of optional keyword parameters. So it says I can say a separator, an ender, a file, and this flush thing. If I pick that file optional and give it this opened file, instead of printing to the command line, it will print to this opened file. And so I see nothing on the output in the console. When I open up my written file, I can see the result of the first write, and then the second write, And then the first print ending with a new line because all prints end with a new line. And then the second print ending with a new line because all prints end with a new line. Often, when I'm writing files, particularly textual files, which is the main kind we typically want to write, particularly early on in programming, we just want to print. We want lines of text formatted the way Python usually formats them, and so the print is often what we want. Write is also available if you want to construct carefully the exact string that goes in and put it in with no new line or the like. Write is available, but usually we'll find that from the rest of today's lecture at the very least, we'll see that print is sufficient. So I'm only going to print, and I'll see only what I print is printed. Any questions about write, print, open, close? Yes?
Is there a way to open a file without clearing?
There is, and we'll see one of those ways towards the end of today's lecture. For now, though, we'll stick with this basic because it's the simplest, I think, to understand. Yes?
How did you get the
How did I open it in PyCharm?
Yeah.
I just double-clicked on it. Other questions? Yeah?
It doesn't matter that the file's highlighted there.
Sorry. It doesn't matter anything that's highlighted.
The file was
Oh, right. This is telling us that PyCharm isn't quite understanding what's going on, basically. So yeah, that darker yellow is Python is confused color. And sometimes it's confused because you had something wrong, sometimes it's just confused. And here it's just confused. Yes?
Is written.txt just supposed to show up on the left side after the bubbles?
Every time I run the code, it will create that file if it doesn't exist, and then write the information to it and close it. So I could write anything I wanted here. If I decided I didn't want to call it written, I could say another, and run it, and proof another will appear. Nope. No, I am not deleting any files. I'm not even going to show you how to delete files today. There are things that allow you to delete files, but that is really asking for trouble. So we won't even bother. Other questions? I have a feeling there was a hand that I didn't get to, but it is not being raised now. Okay. So this is the basics of writing files. And it allows us to do various things, but it is annoying to have to close our files. And it's more than annoying. If our program fails in some way, raises an exception as it's going along, before it closes the file, but after it opened, there's no guarantee that anything I wrote will ever make it to the file. And that can be really bad. If something goes wrong, I probably don't also want everything I thought I put in the file to vanish. And even worse, it is not deterministic how much will make it to the file and how it won't. So if I forget to close or an error happens before I close, sometimes I run it and there will be stuff in the file, and other times there won't, and sometimes only half of the stuff. And that can make it really hard to debug. Because of that, Python has a different keyword that is particularly useful and designed for things like writing files. Instead of writing f equals open something, and then, pardon me, and then do some work, and then f.close, Python realized usually when we open something, we want to guarantee that it closes. And so they actually added into Python a whole new keyword control construct, like if and while and for and def and so on, called the with. I can say with my open as f. This does the same thing as f equals open, except it creates an indented block of stuff to write stuff in, to do whatever I want to with f, and it guarantees no matter how I get out of the indented block, whether I get out of it by an error or just by running down to the end of the program or whatever it is, however I leave that, I'm guaranteed at the end of the indented block the file will be closed. And this can ensure that what I open gets closed. When I'm reading files, it's just sort of vaguely nice to close files. It's sort of polite, and not much more than that. When I'm writing files, this is really important because it tells me I can count on the things I wrote actually make it out to the file. So this program, I'm just going to modify to use that format. I don't need to close. I change this to a with open as F, and then I indent the stuff I wanted to do while the file was open. And that's it. Okay? That's all I had to do. Let's put this back to written, why not? So both lines 1 through 6 and line 9 through 11, they each open a file, they each write 2 lines, they each close the file. But the way I have done it in 9 through 11, in addition to doing 1 line less code, is also guarantees that even if something goes wrong, I will still see what I tried to print to the file, making it into the file. And so from here on out, I will use this second form in the examples we'll do today, because it's a little harder to mess up using the second form. There are occasionally cases where the first form is nicer, when you want to do lots of different things, or open a file and return the open file or the like. But for most cases, the with will work out nicely. Thoughts, comments, questions? Yeah? I do not believe there is, sorry. Other questions? Okay, let's see an at least theoretically interesting example. Let's suppose I wanted to have high scores. This is something a few of you have asked about for your game. Could we have a high score board? And thus far, the answer has basically been no. But today we're going to show how that works. Now, I'm not going to do this in GameBox, because that brings in too much tangential code that will sort of distract from the main thing. So I'm going to start with just this simple little model. I'm going to say name is input, who are you? And I'm going to say score is an int of an input. What was your score? You know what, I won't even need the int for this case. We'll just leave it as a string. Why not? And then I can print, for now I'll just print name got score. And I can say I am Luther and my score was 12. Oops, I missed a space and it says Luther got 12. Hooray. Now let's see how we put this in a file. And for the sake of simplicity, since we spent more time dealing with this kind of file than others, let's put it in a CSV file. So I want to take my name and score, and I want to write it to a file. So I'm going to open scores.csv in writing mode. And then I want to print the name and score in CSV format into the high scores. So I'm going to print name and a comma and the score into the file. Oh, I didn't give it a name. Let's give it a name. Into the file F. So now this program will still ask me my name and score. My name is Quux, and I made 1, 2, 3, 4. And over on the left, I will see this new file appear, scores.csv. And when I open it up, I see it contains the line that I told it to do. Now that I've gotten it into a file, I can read that file to find the list of high scores. So maybe before I ask your name, I can say with open that same file, but in reading mode, which is the default we've been using all semester. So if you don't have the second argument, it'll assume you're in reading mode. So I can read it, open it up in reading mode, and then I can use this CSV the way I always use CSVs, right? So I can say for line in F, name score is going to be line.split on the comma, And then I can print out name got score. Except I didn't call it name, I called it n. So now my code opens the existing CSV file for all of the lines, splits it out, and prints out some sort of high score message. And then it asks me my name and score and writes it into the file. And so since I just ran this and currently the file says Quux got 1, 2, 3, 4, when I run it, I will see Quux got 1, 2, 3, 4. And I am Zixi, and I got -14. Okay, so now Quux got 1, 2, 3, 4, Zixi got -14. I can come in here again and run it, and it doesn't have Quux. Because on line 9, I erased the old file. When you open a file for writing, it erases the old contents. We will see how not to do that here in a moment, but first let's talk about how we get around this fact and how we make sure that our code works. So before I fixed this fact, it erased the content to write the new content. Any questions about my code? Anything you would like me to clarify? Yes?
Line 3 and S.
Yeah.
Can you explain that?
Yeah. So we did this a long time ago, and it has been a while. If I put two variables equals a collection of two things, it will unpack it into the variables. So since I know there's going to be 1 comma, this will work out fine. Technically this could break. Let's break it. If I say my name is something that breaks CSV, and I made 1, 2, 3, and now I look at scores, I wrote something that breaks CSV by putting commas in my name. And now when I run it, it blows up. We will not spend time today talking about how to error-proof our code and avoid malicious input. So we're just going to assume for now that there's only 2 things, and therefore when I split it, I can assign it to 2 variables. So let me update this so that it can run. And we're back to where we started. Other questions? Yes?
Would there be a practical limit he can be used in overall?
No. Particularly for reading, there's no obvious advantage to using with, except it's consistent with how you write. For writing, this works just as well as long as I also close it. But I find that if I just say files always use with, then I always write something that I don't have to remember to close. Yes?
You know why it tells me that the such power and
Yeah, so if I run this program before I've created scores, or if I come over here and I delete that file, and then I run it, it gives me an error. You can't open a file in reading mode unless it exists. Reading does not create files. I can open a file in writing mode even if it doesn't exist, because it'll create the file for me. So I want to create the file first. There are various ways of doing that. One of the simplest is I just run it once without reading it, and poof, the file will exist. I can also use file new. There is also a special mode called R+, that will create it if it doesn't exist. I'm wrong. It's called, I can't remember what it's called. There is something I can put there that will force it to exist. Maybe it's W+? No, because that'll erase it. I didn't remember what it is. So just run it once. That did run, but I think it would also have erased it. If you just run it once without the reading, then the file will exist and you'll be good to go. If you decide to do something like this for your game, just submit an example file and then it will exist when we try to run your game. Yes?
Technically, line 6 and 7 would happen first, right? Before line 1?
No.
No?
Line 1 to this, these lines happen in the order they are written. With the exception we have a loop, so 3 and 4 may run several times. Yeah, so with is not the same as def. It does not write something to use later, it does it now.
Oh.
Other questions? Okay. Right, let's kill this program because I don't want to type things. So right now this keeps only one score. If I want to keep several scores, then when I'm reading, I need to keep around what I got. So I can make a list of scores before I read the file. And in addition to printing out the high scores, I could add to that, I don't know, let's just add the whole line. By doing this, I keep around a list of everything I read from the file. And then when I open it for writing, I can just go rewrite all of that information. So I can first say for score in, for line in scores, print the line into the file F. Now, my first few lines read the file, print stuff out because I cared what was there, but also store everything I read into a list. I then get the new information, and at the end, I open the file, I write everything that used to be there to restore its old contents, and I print the new thing I wanted to be there. And so now, if I open up scores, I'll see it just has the last thing I typed. I run this program, I can say I'm Zixi, and I got 123, and now when I click over here, I will see it has both of those lines. But it also has a new line in between, a blank line. That blank line is going to cause my program to crash next time I run it because I can't split the contents of the blank line. The reason the blank line appears is because of how I've written my code. When I look at each of the lines in a file, either with a for loop or with read lines or read line, however I want to get them, the new line at the end of each line is included. So this line here ends with a new line, which means the lists inside my scores end with a new line. And I can see this by printing out those scores. Although I can't get that far into my code. So let's print the scores over and over again. So I see that first line is name, number, new line. So I have new lines inside of my scores. And those new lines are then being printed over here, and print adds another new line. So I'm getting two new lines at the end of each line. There are lots of ways I could get around this, but let's just strip. Because we've seen how to strip before, let's just strip. So I'll strip the line. I'll also edit my file so it's a valid file. And now I'll run this. And now it knows about both of my names, and I can say Quux, and I can say Quux got negative 123. And when we come back over here, I'll see they're all right next to each other because I've gotten rid of that extra new line I get from reading. So I have this program now that does a little bit better. It reads the scores, stores them without the new line, asks me the new thing to do, and then writes all of the old scores as well as the new score. Thoughts, comments, questions? Okay. Let's make this run a little nicer. Maybe I want to sort the scores. I want the high score to appear first. I probably also don't want those annoying new lines between each of the printed high scores. So we're going to adjust how things work. The simplest way of making sure the scores show out in the order I want is I read them into a list, then I sort the list before I print them out. So I will say, okay, this part here, the printing should happen later. So I could say for score in scores, and I can do the printing out here. I can put that over here as well because this is where I actually need to split. And then in between, I can do scores.sort. So now my code makes a list, reads everything in the file into the list, sorts the list, prints out the lines in now sorted order, then asks me the information and stores them back into the file. So I look in scores, I will see it's Luther Zixi Quux, 23, 123, negative 123. I run this program and I will see it is Luther Quux Zixi, because it has sorted the lines in alphabetical order. And when I type something new, I can say I am Baz, and I made 5676. I will see it wrote them back out in the sorted order, and I'm writing contents of the list as it appears, and then puts the new thing at the end. So this is nice, but it doesn't sort by score, which is probably what I wanted to do. To sort by score, I'm going to rearrange what is inside my list of scores. So instead of just putting all of the lines, let's split the lines up. And let's put in here lists of score names. The score comes first. By putting score and then name, I'm going to sort by score. And so then here, I can say the score and the name is the line, because it's not actually a line, it's now a pair of things that I put into that. Okay, I can print them out. I need to do the same thing here because I've changed what they are, what's stored in the list. So I could change this to be a pair as well. And then instead of printing out the line, I can print the name, a comma, and the score to put it back into the file. So, now I am sorting my scores before I print them out, and I'm sorting them by score. So now I see Quux got negative 123, Zixi got 123, Luther got 23, and Baz got 876. So they actually are being sorted by score, although I've got extra new lines. Let's get rid of the extra new lines because they're going to mess up what I do over here. So, oh right, I haven't typed anything yet. Let's stop that before it does this. So let's make sure I get rid of the new lines by stripping before I split. And I can see the order here is sorted by score, but it's sorted alphabetically by score. Which probably doesn't make a lot of sense, but hyphens come before ones, ones come before twos, and twos come before eights. So it's sorting the scores as strings, not as numbers, which is not really what I wanted. Questions about how it's doing that? Okay, let's fix it. I can just put the integer version of the score in there, and it'll sort it as a number. So if I sort numerically instead of stringly, I see it has them in numerical order. I also notice though it's in ascending order, and usually high scores should be in descending order. So let's reverse this after I sort it. And now I see the high score first. Hooray! That's probably what I wanted. And I can type something in here, make sure everything still works. I can say I am, oh, I don't know, let's have Zixi do something again. Let's say Zixi this time got 48. But now I have an error because all of my scores are integers, so I need to turn them into strings before I can add them to this comma. Do that again. Oh no! Now notice, it blew up. It blew up right away. It blew up the very first time I tried to do something with an open file. So nothing got written. My whole file got erased. This is what I mean by things can go wrong. I opened the file before I could write anything. I had an error. The file is empty. Okay, so we're going to have to start from scratch. We can say Zixi got 123, and we can then say that Quex got 458, and we should now see them both. Hooray! And we can say that Baz got 9123, and so now I should have multiple scores in there. Thoughts, comments, questions? Okay. I can do other nice things when I'm handling things in this way. I could, for example, ignore negative scores. So I could say something like, if the integer score is greater than 0, then put it into the list. And I could filter out what's there and only save some of them back to the file because I ignore some of the ones that were there, and so on. There's various kinds of things. I could only take the first few scores after I sort them, ignore the rest. Lots of ways of modifying because I'm rewriting the entire file every time. So this is the basics of how we write files. Anything you'd like me to describe more about this code? Okay, let's see some other fun things that files can do. I'm just going to search for Python 3 file and trust the first thing from docs.python.org to work. The input and output section of the Python manual starts by talking about just print and strings, but then it comes down to reading and writing files. And I went too far. This talks about a lot of things, but let's just look at this first paragraph of what it says. And I look here in part to comment, we're getting towards the end of the semester, and the next time you want to do something you don't know how to do, you'll probably have to look it up. And you can certainly ask random questions online and hope somebody knows the answer, but often the manual will be the right place to look, the official documentation. This tells us that the first argument is a string containing the file name. We've seen that before. Right? All the time we've been opening files with a file name first. And then it talks about this second argument. It's another string containing a few characters describing the way in which the file will be used, or the mode of the file. The mode can be R, when the file will only be read. W for only writing. An existing file with the same name will be erased. And A opens the file for appending. We haven't used A yet, so we'll talk about that in a moment. Comments there that any data written to the file that's open in appending is automatically added to the end. And then R plus opens the file for both reading and writing. The mode is optional and R is assumed if it's omitted. It says other interesting things about files that we won't go into right now. But there is this third mode, appending. And appending has changed in how popular it is over the years. In the early days of computers, disks were not large. The first hard drive I had and my family computer was about larger than most computers nowadays and only stored 20 megabytes. And we were excited because disks we had before that only stored 1 megabyte. They used to be quite small. Now they store terabytes, and it is hard to describe how big a terabyte actually is. If you and everybody you knew read as fast as you could for your entire life, you wouldn't be able to read a terabyte of text. It is just gargantuanly large. And then we store gargantuanly large things on it, like videos, which store for 60 frames a second, several million pixels and several different characters of information, and go through huge quantities of data very fast, which is why we need big disks. But for the things we're writing in text, it is basically impossible to make your program run long enough to write enough text that you care about disk space. So early in the days of files, it was important to erase what was there before and only write back what was necessary to save disk space. But now that's not really important. And so I can open a file in a way that says never erase anything. just take new information and stick it into the file on top of, or at the end of everything that's already there. These are what we call append-only files. You can never change anything, you never put something in the middle, you just took new stuff at the end, and that only. And for many purposes of files, this is a convenient model. I never have to worry about deleting information, I just have to make sure the new information I put is in a valid format so I can still read the file. So let's take our code, let's first show the basics of an appending file, and then we'll show how that will make our high score code simpler. So the basics of an appending file will be the same as other things. I'm going to say with open some file, add to me.txt, I will open it in appending mode, give it a name, and then I'll say I'll say print something to F. Let's print a random thing to F. So let's import random, and I will print random.randrange between 0 and a really big number to F. And I'll run this file. It doesn't do anything except create a file called add to me. And now I see it happened to randomly create the number 46,759. I run the file again, and a new random number was added. I run the file again, and a new random number was added. Every time I run the file, it will add a new random number, and the file will just get longer and longer. When I open an append, there is no way to delete anything, so I never have to worry about erasing. It will always add new information at the end of the file. Questions about opening in append mode? Okay, let's then see what happens if I change my high scores to append. The simplest thing, basically all I need to do, there's a few other things I could do, but basically I just open it in append, and then I don't have to write the stuff that was already there. And that's essentially all the change I have to write to this code, because I had already written all the other stuff I wanted. I could just say, hey, open it for appending, write this new thing to it. I don't have to worry about rewriting all of the other stuff, because all of the other stuff is still there when I append. So now I can say that I am Basil, and I can say my score was -23, and now my scores will just have that appended to the end. No need to rewrite the old information, no ability to remove information I didn't like, but it adds the new information to it. Which can be safer, can be simpler, as long as having duplicate rows is okay. As long as having multiple entries that look the same is a thing my program can handle. Thoughts, comments, questions? Okay, we're basically out of time. Let me just review and reiterate a few things. When you open a file, if you open it for reading, you get a copy. If you open it for writing, it creates a temporary copy in memory. But when you close it, it's going to send all the information you told it to write out there to memory. Because it only happens when you close, the with command is useful because it will automatically close. But be careful, because when you open a file for writing, it will erase the contents that were already there. So make sure that you meant to open what you open before you run your program so you don't lose information. A slightly safer way of doing that is to open in appending mode, which will not erase the old file, just add things to it. And hopefully you'll find that useful. When we come back on Wednesday, we'll probably talk about how the internet works and how to be a good internet citizen, although we may talk about something else if you ask me to. I will see you all on Wednesday.